I want to do a quick video on area model division. In our example, we have two numbers, 656 being the dividend, 3 being the divisor. The result of that operation will leave us with a quotient. These are vocabulary words that our fourth grade students would need to know. And as we begin doing the area model for this operation, we'll be starting with the idea that we're dividing the dividend into 3 separate and equal groups. In the past, the numbers were small enough, the dividends small enough, that we could share one at a time. For example, 9 divided by 3 would be shared 1, 2, 3, 4, 5, 6, 7, 8, 9, for a total of 3 in each group, or a quotient of 3 in each group. These numbers now in 4th grade have gotten large enough that that's just not an efficient way of doing division. The idea is the same, but the efficiencies require us to come up with another way of doing it. Most people, and eventually your students, will operate using a standard algorithm that looks like this. They'll go through the same steps and processes that you use on a daily basis if you're happening to do long division. But using an area model can be an effective way of doing it. I've found that it's an efficient way of doing it, and with 4th graders tends to produce a lot fewer mistakes. So let's get started. The dividend is written underneath a rectangle that's large enough to work inside and on top of. We're going to be putting the divisor on the left hand side of the rectangle. Now the rectangle does in a sense represent the area of the total 656. This area can be divided up into different parts. We've been working with the students all year on multiplying numbers such as 1,000, 100, 10. And the students are pretty good at this. Anytime you multiply with a factor that has zeros at the end, it's a relatively easy operation, and the kids have gotten pretty good at this. My question to them would be, instead of sharing groups of 1, can you think of a big group that you could share that might be one of these easy numbers? For example, could we put 10 in each group with the amount that we have to share? And of course the answer is yes. Could we put 100 into each group? If we did that, that would be a total of 300, and we have 656 to share. So yeah, we could do that. We keep asking these kinds of questions. If we can put 100, could we put 200? And in the case of 200, if we did put 200, most kids understand that this would equal 600 by multiplying the 3 and 2 equaling 6 and adding the 2 zeros. 3 times 200 is a pretty easy multiplication for them. So that's going to put us right in the ballpark of our number that we're dividing. We have them write this on top, section off part of the rectangle, and show what that part equals total. Now really what's going on is they're putting 200 in each one of those groups for a total of 200, 400, 600. If they subtract that from the starting dividend, they see that they have 56 left to share. So we're going to divide 56 now into the three groups evenly. Well, keeping with easy numbers such as 100, 200, I would ask them, could we share 100? And the answer, of course, is no, because 300 is too much. We only have 56. So what about 10? What would happen if we shared 10 in each group? How much would that be? They're going to know right immediately that that's 30. And well, we've got 56 to share. We couldn't share 20 in each group because that would be too much. That would be 60. So I probably would encourage them to go ahead maybe and share 10, or possibly some number in between there. But again, we want to keep the multiplication easy. So I would encourage them probably to share a group of 10 for a total of 30. Again, 10, 10, and 10. So we've now shared 30 of the remaining 56. That leaves a total of 26 left to share. By now most kids know their threes well enough to realize that we're talking about 3, 26, and the third factor, 8. If they share 8 in each group now, it's a total of 24. That leaves me with 2 left to share. And the problem that we have now is, of course, the amount we're sharing, the amount we have left to share, is less than the number of groups that we're sharing in. So our sharing is finished. This number represents a remainder. The numbers on top represent partial quotients. If we add the partial quotients together, that will give us the total quotients, the total quotient of our division operation. So in the end, we've got a quotient of 218 with a remainder of 2. On a standard algorithm, of course, they have to remember or realize how to bring down numbers. They have to follow these set procedures, or they may very well make a mistake. In the end, we end up with the same number.